Today, I want to introduce you to CRYENGINE's dynamic response system. We call it the DRS. And the DRS was born of people saying, I want to do that, but then asking, why can't I do that? The game designers wanted the AI to call out your location when they spotted you in crisis. The level designers wanted realistic NPC chatter from the civilians in Rome's marketplace. The audio department wanted a player voice that would change its tone from shouting to whispering, depending on whether they were in combat or sneaking around with the nanosuit stealth mode on. I wanted to do clever things that I designed on paper, but once implemented in the game became a horribly complicated, untestable mess. The DRS was the answer to the question, why can't I do that? So, how does it work? As I said, the DRS stands for the Dynamic Response System. It gives us context-based dialogue. It gives us dialogue that is game-relevant and organic. Where a scripted dialogue system will play dialogue in one place at one time, a state-based system looks at the state of the world at any given moment and decides if a line of dialogue should be played, and if so, which one. If you wanted a line of dialogue to fire whenever the player was near a box of ammo, for example, then a scripted system, you would have to place a proximity trigger near every box of ammo and fire a dialogue line when the player was in that trigger. A state-based version of the same dialogue would poll the state of the world, and if the player was near any ammo box, then it would fire a line of dialogue. One system handles the same kind of dialogue much more simply than the other. The DRS fundamentally changes the way you think about narrative in games. Instead of the old linear way of play this dialogue here, then play this next dialogue here, you are forced to design in a way that creates dynamic narratives. You don't ask, what line do we play at point X? You ask instead, given the story we have, given the characters we have, given the choices the player has made, given the situation we find ourselves in, given the last line of dialogue that was played, given the experiences of the characters in the game so far, what is the best line of dialogue to play here? And one thing to bear in mind, while you listen to this presentation, we call it the dynamic response system, not the dialogue response system. That's because it can, and maybe should, be used for more than just dialogue. Music, AI, particle effects, any event can be fired through the DRS. You could potentially design the whole game that way. This is the old system that we used when we created games like Crysis. This is the old dialogue system. What you can see here are the different ways of triggering the dialogue. We have flow graph, which would call the DLGs, which are the scripts which held the file names. That would play the dialogue. The AI system would also go through the communications layer and call dialogue. Cinematics would also call dialogue through track view. The biggest problem with this old system was that the logic control for the dialogue was distributed over different systems, all of which were competing with each other. It made it difficult to design for and manage. It meant that when deciding how a line would play, it was necessary to talk to many different departments. It meant that dialogue from the three different systems were conflicting with each other, making design and control of the dialogue in the game quite problematic. Dialogues from any of the three systems could play at any time, overlapping or interrupting the others. And that would mean we'd have to use blunt tools to control the situation, like shutting down all but one system or giving one system the power to override the others. So, for example, we might say that whenever an event played in FlowGraph, the AI system would have to shut off its dialogue system until we'd played the dialogue that was necessary for that event, and then we'd turn it back on again. Same for the cinematics. And more than anything, none of the systems were actually very good at controlling dialogue. FlowGraph had a hacked control system, the AI only controlled the dialogue with reference to the AI system, and TrackView didn't have any logic at all. None of the systems were aware of what the other systems were doing, and typically lacked any awareness of what was happening in the game world. FlowGraph dialogue wouldn't know if the player was in combat or sneaking about, and AI dialogue wouldn't know where the player was in the progress of the campaign. And for example, in Rise, we had Briton enemies who would tell the protagonist to go home, and he would say that even when he was actually in Rome itself. We needed one system to control all the dialogue, and a system that would have awareness of the state of the game world when it played that dialogue. We needed a state-based dialogue system. In simple terms, the DRS is a black box. You put in the state of the game world, and out comes the dialogue. Signals can come from anywhere. code, flow graph, or even the DRS itself. They are just a way of telling the DRS that something interesting has happened. The DRS can then use its logic to decide whether to do anything about it. A signal is any interesting event that happens in the game world. You must define what is interesting, and you must tell the game to fire that signal. Some examples are reloading a weapon, an enemy AI spots the player, a scripted event starts, and the player dies. Game states tell the DRS about the world and allow it to make decisions. States are usually delivered to the DRS with the signal as context. For example, a button press signal would come with the context of which button exactly was pressed. For level design, the DRS can additionally reference game tokens directly. Any state present in the game world can be used by the DRS to decide which line of dialogue will be played. And for example, a game timer will tell you what time in the game is, the player health, the AI weapon type that it's using, your proximity to an object, and the objective status, whether it's been completed or not. The DRS can also create its own states. You can create them yourself in actions. The DRS will also create some automatically. Some examples are time since the dialogue last played, how many times that dialogue has played. We can also do signal ignored. That means that if a signal is fired and the DRS doesn't deal with it, we can set a flag within the DRS to say we've ignored it. A banned dialogue flag you can use to disable all dialogue currently or in any particular situation. And you can also set a flag which will define that an actor has spoken. And if an actor has spoken, you might not want him to speak again for another 30 seconds, especially if he's doing systemic dialogue like saying reloaded or enemy spotted. You might want to keep him quiet for a certain amount of time until you want him to talk again. All states created by the DRS can be given a cooldown period. The cooldown defines how long the variable will be set to the new value. Once the cooldown period is over, the value of the state resets to 0. This is useful if you want to set a variable that says something like actor has spoken, or ban all dialogue, and only have that set true for a certain amount of time, say 5 seconds. The DRS receives signals and states continuously, and passes them through the logic of all possible responses. If the conditions of the responses match the signals and states, then it takes an action. Typically, that action is to play a dialogue, but it could also be to fire another signal, or even play music, display text, play an animation, or activate any other system you set the DRS to communicate with. So, why is it good? It's a single system which knows what dialogue is playing at any time, and can understand the state of the game world at any time. This gives us the power and fidelity to create dialogue that matches the game world and situation, that is credible and human, that is rich in variation but not random. It also makes the whole process much simpler to design, implement, and manage. What we have here is an example of a dialogue design. This is a design for a single line of enemy spotted dialogue, broken down into fragments. Each fragment can be played depending on whether the appropriate rule is matched and if the context is correct. Assuming this is a soldier speaking to another soldier, typically they want to convey some vital information. What kind of enemy, how many, where are they coming from, where are they, whether they are attacking you or just on patrol. It's also quite possible that the information, like the number of enemies for example, will change as the person is speaking, because more into the area. So that's what this design aims to cover. A state-based system also allows us to test the combat status of the soldier who is speaking the line. This will change how the line is said, and also change the dialogue itself. So, for example, a soldier will shout the information when in combat, because there'll be a lot of gunfire. They might also omit some of the information, as it isn't such a matter of life and death. They might also add some more swearing. A state-based system also allows us to change the line as it is being spoken, as the status of the game changes. So, if the soldier is calm at the start of the line, because the enemy hasn't seen him, the dialogue can change as the enemy notices him during the delivery. He can ratchet up the tension in his voice naturally in reaction to events as they take place around him, as you can see here. So the green is the AI idle, yellow is AI alerted, and red is the AI is attacking. And you can see the fragments can be played here in green, and then we have a different fragment played when the AI is alerted. And then finally we have the last few fragments of the sentence played when the AI is in combat. We can see how that works here with the dialogue examples. When the AI sees the enemy, you can say, I see one, and he defines what type it is. He says, Walker. But then, as he's explaining that to you, he notices that the AI state has changed and it's now alerted. And also he notices that the number of enemies is different. So he says, make that 2, heading this way. He's getting a bit more anxious now. Then finally we switch into AI combat and he can start shouting, there, by the shed, get ready, shit, there's 2. So he's changing the status. He's delivering corrections to the information that he's given you dynamically as the game is progressing. The resulting dialogue is much more human, contains vastly more information, and is rarely likely to repeat itself. And you compare that to your standard 6 variations of enemy spotted, and you can see there's a huge difference between what the DRS can do and what our old dialogue system can do. So now we're going to do a walkthrough. And for the walkthrough, we will use a game we made last year called Robinson. Robinson is about a boy who crash lands on an alien planet. And the only person he has as a companion is a robot. What we will do is move into his pod to see his daily life. And part of his daily life is to call out on the radio to see if there are other survivors. And if you don't do that, Higgs is going to remind you. We're going to give you a hint about using the radio. To set that up, first of all, we need to go to the DRS, Dynamic Response System. And what we'll do here is, as we have it already set up on the dialog line database, we need to create first a reference in the database, which will tell the DRS which line of dialogue to play, and also tell it some basic management information. So we'll insert a line, and we'll give it an ID of LI radio hint. Now, LI is just a convention that we use. LI stands for line. We have SG, which stands for signal, and over here you can see play DG. DG stands for dialogue. We use that convention to maintain consistency across the assets, and we try and have all the assets having all the same name. So radio hint will be LI radio hint, and that will be called by the response SG radio hint. That's not always possible, but generally it works, and it's actually very helpful. So as you can see, when I go to line start trigger and I search for the audio file name, all I have to do is type in radio hint, and you can just double click on there and we have the line ready to play. One of the things you can do in terms of managing the dialogue is to set the priority. Here we have it set by default to 50. Priority works by helping you to deal with multiple lines playing at the same time. So the question is, what happens when you have a line of dialogue playing and another line of dialogue is required to play at the same time or during that line being played? We have a priority system which deals with that. And if a line is requested to play that has a higher priority than the one line that's already playing, then it will interrupt. If it's a lower priority, then it will be ignored. As you can see, this one has a default of 50, which we will keep, but over here we have one that says systemic Robin dies. Now, obviously, if Robin dies, that's a really important event, and so we want Higgs to talk about it, so we give that a priority of 100. And that means that it will interrupt whatever he's talking about at the time, because if he's talking about a radio hint and you want him to talk about him dying, then having 100 priority will make sure that he does. Next to that, we have the selection mode. Now, most games will have a selection mode which is basically random variation, and that means that it will pick one of 5 of your variations at random and play that. So, you know, if you have a enemy spotted line of dialogue, it will just say one of 5 variations of enemy spotted at random. We've improved upon that, and we can actually choose quite a few different variations in terms of selection mode. Obviously, I've just mentioned random variation, but you can choose sequential variations, repeat all. That will go through each of the variations that you have in sequence and play them. And when it gets to the end of the variations, it will go back to the beginning again. We also have sequential variations clamp last. That will go through each of the variations in sequence, and when it gets to the last variation, it will play that variation again and again and again. We also have sequential all. That plays every single variation that you have all at the same time, every single time you call it. And we also have sequential only once, and that will play each one of the variations in sequence once only, and when it gets to the end, it won't play them again because they only play once. So we're going to select sequential only once because this is a hint. We don't want it to play multiple times. Also, as it's a very specific line of dialogue. It'll make Higgs sound like a robot if he says the same line over and over again. And even though he's a robot, we want him to sound like a human. In here, we can put the subtitle. This is only for your own reference, but it helps when you're debugging. So we'll just put in, why not call out for survivors? That's part of the line of dialogue that plays. Next to that, we have the afterline pause. Now, typically when dialogue plays in a game or when it's being played by the system, it will play without a pause. And most humans actually talk with a pause. Typically, we find about half a second. It gives you a human-like dialogue response, but sometimes if you want to emphasize something, you might want a little bit longer. Then finally, we're going to look at maximum queuing duration. Now, we talked about priority earlier, and what happens to lines of dialogue that get ignored by the system because they are a lower priority? Well, what we can do is we can actually put them in a queue and have them wait until there's a space available for them to play. The default value here is -1. That means they'll queue indefinitely. They'll queue until the game is finished, but that typically isn't very good because you don't want a line of dialogue reminding the player to use a radio when he's wandered off into the jungle and it plays like 4 minutes later. So typically here we would only use values of about half a second to 1 second, and we find that will normally smooth out most of the problems with normal dialogue between two actors in the same scene. To make that work, we will need to have a signal being sent from the engine, from the game. The signal can come from anywhere. It can come from code, it can come from schematic, it can be sent by the DRS itself. The DRS can generate its own signals. Or you can set it for flow graph. And as flow graph is the simplest way of creating signals, that's what I'm going to do today. So we're going to drop it into the audio layer. I'm going to put it over here. And we say add node, dynamic response, send signal. And in there, we're going to give it a signal name. Like I said before, we're going to stick to the naming convention. We're going to say SG radio hint. And if you see here, we have context variables. I'll talk more about variables later, but you can actually send variables with the signal, and these can specify information like if it's a signal being fired on proximity to an entity, you can send as a string context variable, for example, the distance between the player and the entity that is firing the signal. We're not going to put any context on this signal because it's quite a simple one. Over here, we're going to look at the dynamic response. Now, the dynamic response needs to be triggered, so we're going to add the game start node. We're just going to send the signal at the start of the game. And a very important thing to know about the DRS is that the signal is always sent on an entity. In this case, we're going to send it on global AI Higgs because that's the name of the robot entity that is going to play the dialogue. This is important because when it plays the dialogue, it will play it on the entity that calls it, and that entity needs to be voice-enabled. It needs to have a bone within its rig that will be able to play the dialogue. The problem is here that, and you can do this with your own project, Robinson has its own custom node, which we used in production, and we can find it down here. And it's basically exactly the same, but we had some additional functionality that we used at some points during the production. Here it is, call play dialogue. And we'll just drop that over here, and instead of calling that, we will call this node, and instead of putting that as the entity there, we'll have that as the actor ID here. We need to do force play, and we'll put the same signal name in here, SG radio hint. Now, we'll leave that there because it's not doing anything. Moving back to the dynamic response system, we need to create the response that will play the dialogue. This is the response that will respond to the signal that we're sending. We will create here SG radio hint. We click create new, and you see we have a base response here. Now, the response can be very simple. If you don't want to do anything but just play a line of dialogue, you can just simply go insert to the actions, and a speak line will come up immediately. And as you can see here, it's trying very helpfully to maintain our file name convention, but it always puts in that SG, which is unnecessary, but there you go, LI radio hint. That will just call the line of dialogue associated with that response. And that's all you need to play a line of dialogue. We're going to do a little bit more complicated logic here, so we'll ignore that for now. We'll delete that. What we're going to do here, this is the base response. This can only have one single response in it. And what we tend to do here is just, when we're in production, we only put in here the things that must happen before the other dialogue plays. And it might be a conversation, it might just be a simple hint, but we always keep it with a base response here. And in the base response, we typically inherit conditions, which is a useful function. Inherit conditions allows you to create a response elsewhere, which defines certain conditions, which you want to use maybe globally or across an entire level, or maybe just for certain entities or certain actors. And here we're going to have game inheritance. And that will allow you to do things like set up a value of disabled dialogue. And you can have in the game inheritance, if disabled dialogue equals 1, then we don't play any dialogue. We don't have any actions here. What we do instead is we create a follow-up response. Now, follow-ups allow you to string actions together. The follow-ups will not execute until the previous actions have been completed. This is very useful if you want to have a conversation between actors, for example. So you can just have a speak line in this follow-up response, then create another follow-up response and another one, and each one of these has a line of dialogue which is associated with a particular actor, and they can just fire back and forth. We're not doing that right now, so we'll remove that. What we're going to do is just have a simple line of dialogue playing here, which is the one we had set up before, but we're going to put it in the follow-up response so we can manage it more easily, and you'll see why we're doing that later when we make this more complicated. We also have a speaker override option here. This, in the speaker option override, allows us to change the actor that is playing the dialogue. Now, as you saw, the flow graph sent an entity as the sending signal. That will be the entity that the dialogue will play from if you don't change it. Now, if you want to have a conversation between actors, obviously, you will need to change the actor that's saying the line of dialogue. Also, if you want to play it safe because you're not sure what's been set up as the entity to speak when the line of dialogue is played, maybe it's coming from the schematic, it's maybe coming from the player and you want it to play off the robot, well, you can force it here. And in this case, we're going to type in AI, global AI Higgs. It's worth noting here that all actions defined in this section here will execute simultaneously. You can add a delay here, for example. We're not going to do that now, but if you want the action to occur slightly later than the others, then you can actually put here a slight delay. But typically, if you want something to happen later, then you create a follow-up response, and the follow-up response will only execute after all the actions in the previous follow-up or in the base actions. When they have completed, then the follow-up will happen, and then when those actions have completed, then the next follow-up will happen. But as I said, we're not going to do that now. So we just have here a simple response which will check the conditions of game inheritance, and if they are correct, then it will speak the line LI radio hint, which we set up earlier in the dialogue line database, and it will play that on the entity global AI Higgs. Now we can test that very easily by sending it through the DRS. And here you can see that it's actually going to play on dude. Dude is what we call the player entity in most of our games. I think you might call it something different, but that's the default name. And that will send the signal off the player. Now, because we've set it up down here to be on global AI Higgs, it will actually change. To test the signal in the game, we can actually do it through the DRS. And it will send a signal on dude. And if we click on the arrow here, it will send the signal.
Why not call out for survivors? Use your emergency radio. Someone might be listening today.
As you can hear, it actually went through global AI Higgs, the robot voice. That's the special effect you could hear on the dialogue. Now, what we have here is the execution info. This is one of the ways you can debug the logic in the DRS. To test this response, we can use an internal test within the DRS, which is the send option here, which will send SG radio hint onto the dude character. When we fire this, it will actually change that to global AI Higgs because we've told it to override the speaker. So it should play through the robot, and you'll hear it with a special effect on his voice.
Why not call out for survivors? Use your emergency radio. Someone might be listening today.
Okay, so it worked. Now if we try again, it doesn't work. As you can see here, we're tracking the responses as they play, and you can see the execution info for each of those attempts at playing. Now, the first one, which is down here. It executed at 40 milliseconds into the game, or whatever that counter is. And it finished. And we can see that as a status. The signal source was the DRS UI. It checked the conditions, inherit conditions from game inheritance, which was met, and that was true. And then it executed speak line li radio hint on actor dude. And it did that successfully. That's why it says finished. On the other one, it says cancelled. And it says cancelled because we set it up to be play only once. And so when it checked in the database, it saw that it was play only once and realized that it had already played. And so it didn't play it and it cancelled it instead. That's part of the debugging tools that we have. We also have dialog line history. As you can see, these are the two executions here. On the one it says done, on the other one it says skipped because no more valid line variations exist. That's because it was play only once. And it tells you the subtitle text, which, as I said, was helpful for debugging. And it also tells you the source. In this case, it was the DRS itself. You also have the variables. You can keep track of that, which is very useful. Here we have all the variables in the game on the left-hand side. Everything that you set up, as you can see, there's hundreds of them in Robinson. And that can be quite difficult to track, but if you have some good tools like we have here, it makes it a lot easier. And here we actually have a history of all the changes to the variables. So you can see the time at which the variable was changed. You can see which variable was changed. You can see the value that it changed from and to, the type, and you can see what was the source of the response that requested the change. Okay, so next thing we want to do is have a look at that in the editor and see whether it works and how it works. I'm going to find somewhere safe and quiet where we won't trigger any other dialogue so we can test it, which is here.
Why not call out for survivors? Use your emergency radio. Someone might be listening today.
Now, as you heard, he played that hint straight away, which is a bit useless because I'm not in the pod. It's right at the start of the game. I don't even know what he's talking about, so that's a problem. How can we fix that? Well, let's give it a pause. We can bring back the dynamic response system here, and in the base here, we can actually tell the DRS to wait. And instead of doing a speak line action, we can choose a different action. That action is wait 30 seconds. That should be enough time for us to jump into the pod and have a look around, and for Higgs to then remind us to use the radio when we haven't bothered to do so. Okay. So we'll save that because it doesn't save automatically, and we'll move the DRS away from the screen, jump into the editor. We're going to jump to the pod, and then we see that, thank you Higgs, get out of the way, and then we're going to go over here and we are going to use...
This is pod 3091659, broadcasting on all frequencies. If there are any other survivors out there, let me know. Higgs is getting pretty lonely.
Is Higgs going to say something?
Why not call out for survivors? Use your emergency radio. Someone might be listening today.
Well, it's nice that Higgs gave us the reminder, but it's rather useless because we've already used the radio, so we need to stop him from doing that. So what can we do to make that work? Let's bring back the DRS. Okay, so one thing you can do is to use variables, and we had a look at the variables earlier in the debugging, but we haven't actually set a variable here. What we want to do in this case is to have the DRS set a variable when we interact with the radio, so that when Higgs comes to say his hint line, he can check that variable, and if it's set to 1, we can just ignore it. So we'll actually go to find that response, which we have already set up, and it's called interact radio. And we can find it down here. Let's remove that. In order to set up that variable, we need to find the response which deals with the interaction with the radio. So we search for interact radio, and there it is. And in here, we can tell the DRS to set a variable before or when the player interacts with the radio. Now, we have 3 different types of collections. A collection, you can call it anything you like, but the DRS recognizes 3 different types of collection. You can have context. We talked about that before. Context is associated only with a signal. So that when that one signal fires and we're dealing with it in this response, context variables only are associated with that signal. You won't get them with anything else. Local is also recognized. Local is associated only with the entity. So when you're dealing with a particular entity that fired that signal, it will have its own variable names under the local collection. And it also recognizes global, which is across the entire game. And we will use global here because we want it to be accessible, whatever signal, whatever entity is accessing the DRS. And what we will do is we will set radio done here, and we will set that to 1 when you interact with the radio. You can have a cooldown as well. A cooldown will reset the value that you've changed after a certain period of time, say 10 seconds, but we don't want to do that, so we're going to have it as 0. And then we save it. Having set up the variable, we want to actually check for it. So we're going to go back to the response that we were working on, SG radio hint, and we will make a check for that. Now, this is where the speak line is happening, and we'll put the condition just before that, and we'll say variable equal to, and we say global radio done. And we only play this line of dialogue if radio done is equal to 0. And so if that condition is true, then the line of dialogue will play. Maybe if you don't play a line of dialogue here because the radio has already been interacted with, maybe you want an alternative to play instead. So what we're going to do here is add a condition which says variable equal to global radio done is equal to 1. This will cause this action to happen if we have interacted with the radio already. So we're going to make this a speak line action. We're going to say li systemic good, and that will play a random variation of good, excellent, nice, whenever this is set to true. And we're going to do speaker override global AI Higgs. And then we're going to save that. This introduces a powerful feature of the DRS. With multiple options in the follow-up here, is child 1 and child 2, the DRS chooses which one to play on the basis of best fit. That means if you have more than one child whose conditions are met, i.e. true, the DRS will check which child has the most conditions, and the one that has the most conditions that are true is the one that it will choose to play. For example, if you have a simple reloading dialogue, and maybe you have 3 different versions of that defined, you might have a basic one that says, well, just play in any old situation, doesn't need any conditions. You might have a more specific one which only plays in combat situations. It might be a bit more shouty. And you might have a variation which is specific to a particular weapon, like a flamethrower. So you might have one that plays on a flamethrower in combat. Now, if the player has a flamethrower and is in combat, then that'll be true, but so will the other ones be true. With the DRS, it will pick the variation which has the most conditions true, the most context. And so in this case, it will be flamethrower with the combat status set to true. That can be a very useful way of deciding to choose dialogue in particular, because it allows you to the more context, typically the more human and the more realistic the dialogue is. Okay, so we're going to test this now. And we're going to go outside and see what happens. We're going to find a safe place to jump into the editor. Control G. We're going to jump into the pod. We're going to access the radio.
This is pod 3091659, broadcasting on all frequencies. If there are any other survivors out there, let me know. Higgs is getting pretty lonely.
And what will Higgs say now? When he's finished blinking.
Great.
He said great. Because we've interacted with the radio, he's not going to give us the hint. He's just said the other variation. Okay, so if we bring back the dynamic response system box, we can see in the signal history, we can see what happened there. So as you can see in the status, it's finished. That means it played the line of dialogue. The source came from DRS signal flow graph, which we set up earlier. It checked the conditions, gave inheritance, that was true. It did nothing for 30 seconds. and then it tried to execute one of the follow-up responses. It first of all checked global radio hint. It checked if it was equal to 1. It wasn't. It was equal to 0, so it didn't play that one. It then went to the next child, and it said, is radio done equal to 1? It was. So it played LI systemic good. So everything worked perfectly. But what if the player goes outside? We don't want to be reminding him about the radio once he's opened the door to the pod and he's wandering around inside the jungle. So we can fix that as well inside the DRS. What we can do here is, again, create another child. And we set a new condition here. And one of the things that the DRS can do is access the flow graph directly through game tokens. And we already have a game token set up in Robinson. It's called Robinson _rescue _pod dot door opening. That means that once the player has opened the door and has left the pod, then that token gets set to true. We can use that as a condition. Here we'll set it to Boolean. It will now check if the game token is set to true, and if it is, then we will play a different line. And here we will play LI global Higgs unit reminders with the override of global AI Higgs. Now, there's a bit of a problem here because now we have 3 conditions, but which one of these 3 conditions will execute? There is a possibility that the player can exit the pod and not have played the radio, and that will mean that both conditions are true. In this case, because they both have only one condition, the DRS will not know which one of those to pick because it won't have a best fit, and so it will choose one of those at random. Now we don't want to have that happening, so we need to be more specific. So what we can do is we can say for the radio hints, we can say that they will only play when the player is still in the pod. So that means they will only play when Robinson Rescue pod door opening is not true. And so what we can do here is add another condition. And we can actually take the condition that we've set down here. We don't have to type all that text again. We can just copy and then paste. And then we uncheck the true box. And then we can save it because we don't want to lose it. And then we can also here insert another condition. And we copy that one that we already made. Put it here. And I'm using the shortcuts now. Control V. And we have it again. So I'll remove that. This should only play the hint dialog if the player is in the pod, and if he leaves the pod, it will play another kind of reminder, a more generic reminder about how cool it is to go off adventuring. Let's test it out. I'm going to move that over here, go back to the editor, find a safe place to jump into the game, press Control G, and now we're going to jump into the pod. I'm going to We're going to ignore the radio, we're going to jump straight out. Higgs is going to say something about the spaceship, which we can't see in the editor.
Still standing, even after a year. Can you believe we used to live on that ship?
And when he's finished talking,
hurtling through the stars
he should give us
67
a hint
million miles
about
per
adventuring.
hour until... I would imagine that if I wanted to go on an adventure like you, I'd probably have to go to some quite dangerous places.
And it worked. So that's it. That's how you can create a fairly simple response in the dynamic response system and have it play dialogue with different kinds of logic. With this webinar, I've only really given you a taste of what the DRS is capable of. We haven't even pushed it to 1/10 of its abilities with our own published games so far. We are even exploring ways of having it deliver audio, manage voice allocation for the AI, and deliver tutorial tips in the UI. Hopefully the information I've provided you with here will help you start to discover what your game is capable of saying.
Achieved with CRYENGINE.